Hello students, welcome to today's lesson where we are going to look at properties of X-rays, hard and soft X-rays. We start with the properties. 1. They travel in a straight line at a speed of light which is 3.0 times 10 to the power 8 meters per second. They are dangerous, they can cause cancer. They undergo refraction and diffraction. They penetrate substances and they are absorbed by those materials that have high density like bones and lead. They affect photographic films. They ionize or they remove electrons from gases, making them to be good conductors. They can cause photoelectric emission, which implies that if they are illuminated on a certain metal surface, then that metal surface can emit electron through what we call photoemission. So X-rays cause fluorescence in certain substances. So in other words, if they are directed to a certain substance, that substance may glow. They are not affected by magnetic or electric field since they carry no charge. They are plane polarized since they are waves. Now, X-rays are electromagnetic waves of very short wavelength and they obey the wave equation, that is C is equals to lambda frequency, and the energy equation, which is E is equals to hf, where h is the Planck's constant and f is the frequency of the wave. Then we move to types of X-rays. We start with the hard X-rays. In hard X-rays, they have high frequency and short wavelength, and therefore they have a high penetrating power. And this one is achieved by increasing the anode voltage in order to give the cathode rays more kinetic energy. When we talk of cathode rays, we are talking of the streams of electrons. So if the electrons have a lot of kinetic energy, they will move with a very high velocity, and that way, on hitting the target, they will give us hard X-rays. These X-rays penetrate flesh, but they are absorbed by bones. So we move to soft X-rays. These ones are produced by electrons that are moving at a lower velocity as we compare them with those in hard X-rays, which implies that soft X-rays have low frequency and longer wavelength as we compare them with the hard X-rays, which again implies that they have low penetrating power. So this one is achieved by lowering the accelerating voltage, and these X-rays are used to show malignant growth in tissues because they only penetrate the soft tissues. Now, if you want to get the quality and the type of X-rays, this one is determined by the accelerating potential. From there, we move to intensity, or what we call the amount of X-rays. Now, the intensity of X-rays is controlled by the amount of heating filament or a heating current, which implies that if we have a greater heating current, you heat the filament, it becomes hotter. It will give us more electrons, and when we have more electrons, then we'll produce more X-rays. That way we are able to get more intense beam of X-rays. The strength of X-rays depends on the accelerating potential between the anode and the cathode. The quality, that is the hardness or softness, is controlled by the potential difference between the filament and the target. So when we are talking of the quality or the strength, we are talking of the same thing. The higher the potential difference, the harder the X-rays produced. From there, we move to dangers of X-rays and precautions. The first one, we have that X-rays can cause serious damage to the body cells because of their ionizing property. Another one is that excess exposure of living tissues to X-ray can lead to damage because it can kill those cells, even the important cell in your body. So that way, you are damaged, your tissues are damaged, or your cells are damaged. Now, the penetrating property can also cause genetic changes and even serious disease like cancer. Now, how do we prevent ourselves from these dangers? One, when you are dealing with X-ray machine, ensure that they have lead shield. This will help the operator, or it will protect the operator from getting the stray X-rays. Then, if you are in a room or the operation room, ensure that the walls have concrete. The concrete will absorb the leaking radiations or X-rays. Then when you are working, reduce the exposure time. That way you're able to protect yourself. From there we go to the applications. In the first one we have in medicine, or what we call radiography and radiotherapy. Now due to their penetrating power, we can use them to view the fractured bone or dislocated joint, and this one is used using what we call X-ray photograph, that is radiography. Then also foreign objects like swallowed coins or pins can also be located. Hard X-rays can treat cancer, that is if you direct them to where we have the tumors or where we have the cancerous cells, then they can destroy those cells, they can destroy those affected cells. That way you are able to be cured. Then part 2 we have in science, or what we call crystallography. You want to study the structure of a crystal. This arrangement of atoms can only be seen through the X-ray photo. In case there are fractures in the structure, again, they can be easily revealed using the X-rays. We go to industries. We use the X-rays to inspect cracks and flaws in metal, or sterilizing surgical equipment before they are packaged. So it means that this surgical equipment, before they come out of the industry, they are already sterilized using the X-ray. Then in security, when you are traveling, they may be outside the country, you always find that they inspect the luggage for any weapon hidden in them. That way they use the X-rays to locate those weapons. From there we move to problems on X-rays. 1. Calculate the wavelength of X-rays whose frequency is given by this one. For us to get the frequency, we use this formula. C is equals to lambda frequency. We know that C is the speed of light, which is 3.0 times 10 to the power 8 meters per second. Now making lambda, or the wavelength, the subject of the formula, you get that it is C of the frequency. Then you substitute the value. You find that if you key in using your calculators, you will get this value. So our wavelength is 5.0 times 10 to the power negative 13 meters. Then question number 2. Find the energy of X-rays whose wavelength is 10 to the power negative 10 meter in a vacuum. You have all these constants. So we get energy is equals to hc of a lambda. We have seen that earlier. We substitute the values. H is the Planck constant, C is the speed of light, and then we have our wavelength as 10 to the power negative 10. When you key in your calculator, putting these values into bracket, you will find that it is 1.989 times 10 to the power negative 15 joules. Note that we are working with SI unit. Then we move to question number 3. The potential difference between the electron gun and the target of X-ray tube is 50 kilovolts. 15% of the energies of the electrons is converted to X-rays. Given that the charge of an electron is this one and Planck's constant is this one and the velocity of light is this one, calculate 1, the frequency of X-rays. So we get the energy first, EV, you substitute. When you put these values in your calculator, you get the value that it is 8.0 times 10 to the power negative 15 joules. But we are told that only 15% of the energy is converted to X-rays. So you get that percentage. 15 over 100 times that. You get that it is 1.2 times 10 to the power negative 15 joules. After getting that, remember our question is asking about frequency. So we have that E is equals to HF. We substitute our E is this energy. Then our H is the Planck's constant, then F is the frequency. So getting F as the subject of the formula, you divide through by 6.6 times 10 to the power negative 34. When you are dividing this, put this term into bracket, then you put the division side, then you put this term again in bracket. That way, you are able to get this value, 1.82 times 10 to the power 18 hertz. Then part B, what is the wavelength of the waves produced? C is equals to lambda frequency. Our wavelength is equals to C of a frequency. We have C as the speed of light. We have calculated frequency. So we substitute the values. Again, key in these values into bracket. First, the numerator, You put the division sign, then you put bracket, you put the denominator, and you will be able to get this as your value. 1.65 times 10 to the power negative 10 meters. Then we move to our next example. An X-ray tube is operated with anode potential of 30 kilovolts and a current of 10 milliamperes. Calculate the rate at which the energy is converted at the target, kinetic energy of the emitted electrons before hitting the target, the maximum velocity of electrons, the frequency of X-ray produced if this one, 0.5% of the energy, is converted to X-rays, the number of electrons hitting the target. We move to the solution. First, we get the power. The power is the same as the rate of energy conversion, which is given by current times voltage. We substitute our values. 30 kilovolts multiplied by 10 milliamperes. You get that it is 300 joules per second. Then part 2, you are supposed to get the kinetic energy. Kinetic energy is given by EV. Again, substitute the values. E is the charge of electron and V is the voltage. When you multiply the two, you get that it is 4.8 times 10 to the power 15 joules. Then part 3, the maximum velocity of the electrons. We have that kinetic energy is equal to a half mv squared. So making V the subject of the formula, it will be the square root of 2 multiplied by the kinetic energy divided by m. After that, substitute the values. Your kinetic energy you have calculated here, it's this value. Your m is the mass of the electron and it's given by this value. So when you substitute and when you are keying in your calculator, put the bracket. That way you are able to get the value as 1.03 times 10 to the power 8 meters per second. But make sure that you are using your calculators and cross-checking these values. Then after that, we move to the part 4, the frequency of the X-rays. Energy of X-rays is HF. We are told that only 0.5% is converted, so we get that percentage. It is 2.4 times 10 to the power negative 17. So to get F, it is kinetic energy divided by H, because HF is equals to energy. So F is equals to kinetic energy divided by H. You substitute 2.4 times 10 to the power negative 17 divided by 6.6 times 10 to the power negative 34. When you put them in your calculator, you will get that it is 3.64 times 10 to the power 16 hertz. Then part 5, the number of electrons hitting the anode after 1 second. I is equals to Q over T. Our Q is equals to IT. And this one we are getting it from the definition of current in Form 1. Current is defined as the rate of flow of charges. So it is Q over T. But our T is 1 second. So it reduces to I is equals to N over N multiplied by electron charge. We are getting N as the number of electrons. Then we multiply by the charge per electron so that we can get the value of Q, that is the amount of charge. So that way we can be able now to substitute. Remember, the question is asking about the number of electrons. So when you substitute, you have the current, you have the electron charge. So you can be able to get N. N will be given by this value. Again, put the brackets, and then you divide again, put this as in a bracket. That way you will be able to get your electrons as 6.25 times 10 to the power 16. Then we have another example. An X-ray tube operating at 50 kilovolts has a tube current of this one. Calculate or how many electrons are hitting the target per second. This one we have done it earlier, so we just get N is equals to I over E. We substitute, our current is 20 milliamperes. Our charge is this one. After doing that, you get that it is 1.25 times 10 to the power 17 electrons. Then if 0.5% of energy of electron is converted to X-rays, estimate the quantity of heat energy produced per second. So first of all, we get the energy, the total energy, that is EV. When you substitute and you multiply, you get that as your energy. Then after that, we get the percentage of the X-ray, that is 0.5%. If you divide by 100, it will become 0.005. You multiply by the energy, you get that it is 4.0 times 10 to the power negative 17 joules. Then after that, remember you're supposed to get the quantity of heat energy produced per second. So you need the energy, total energy minus the energy converted to X-rays. You subtract the two, you get that it is 7.96 times 10 to the power negative 15 joules. Then from there, find the X-ray power output. Power is the same as rate of energy conversion, and it is given by current times voltage. You substitute 20 milliamperes times 50 kilovolts. You get that it is 1000 joules per second. Then after that, we have the assignment. Make sure that you're able to get everything. Practice makes perfect, especially in calculations. Show your neighbor, practice with your peers so that you can be able to get everything. Then finally, prepare for end of topic exam. Thank you, and let us meet in another topic.